you an example. If we have 2 points, this is point A, another point B, cross board. If a particle want to move from point A to point B, how would the particle move? Just follow any path, right? Imagine if this laser point, the red dot, it's a particle. If we want to move that from A to B, I'll just go to A to B, follow a certain path, whatever path you want to go. Okay. We don't really care about the size, the shape of that dot, since that's a small dot particle. What if we have a rigid body? Now we have something that has shape and size. Just imagine this is a rigid body. My iPad. Not my iPad. Actually, this is my wife's iPad. That's why it has this color. All right. Some of you probably had that question. Why Dr. Al picked that color for his iPad? No, not mine. Okay. If this is the rigid body, how this rigid body move from point A to point B? Well, you said it can go the same thing, just like that particle did. Well, you can follow any path. Boom. Now you're at point B. But now we have a rigid body. I can also do something different. I can also do, how about rotate this way? Oops, no. Now I'm still moving from A to B, right? Okay, how about now? Let me add some more complicated rotations. Boom, right here. So there's different ways I can rotate like this. See, my screen's also rotating. So cool. Okay. So when you have a rigid body, that is something has a shape and size. We move from a point to another point. It's not just what's the path of that rigid body, the movement. You also have, what is that called? What I'm doing, rotation. Yes. So on the top of what we learned from chapter 1, in chapter 2, 2 new things come up. It's called angular velocity and angular acceleration. That is unique to rigid body. Could particle has angular velocity, angular acceleration? Could particle has that? Okay. All right. So we're going to start from chapter 2. We're going to talk about section 2A. We're going to learn 2 new equations. And the first equation, it's about velocity. A velocity on rigid body can be calculated by using another point velocity of another point on the rigid body plus the angular speed omega, angular velocity, in this case, cross product RB/A. So that this is the first equation for chapter 2A. Okay. So A and B are the 2 points, any arbitrary points on our rigid body. So assume this is our rigid body, and there's one point is A, another point is B. Okay, make sure you write a note there. On the rigid body, the distance of any 2 fixed points are also fixed. So on the rigid body, we have these 2 fixed points A and B. The distance between A and B are also fixed. Doesn't matter how your rigid body is moving. The distance on 2 points on the body are constant or fixed. And in order to apply that equation, the first equation, that 2 point A and B inside of the equation must be on the same rigid body. Same rigid body. If I have another, if this board is my another rigid body C, I cannot use that equation try to build a link between VC equals VA plus omega cos R something slash something. The 2 points must be on the same rigid body. Okay, let's look at this equation. First, when you look at that equation, they're all vectors. Both VA and VB are vectors. Omega here, write a note down. It's angular velocity of the rigid body. Angular velocity of the rigid body. It's the same rigid body A and B are on. Okay. Okay. Now let's look at this term. RB/A. Write it down. That is the position vector pointing from A to B. So it's a vector pointing from A to B. So the letter after that slash, it's your starting point. The letter before that slash sign, it's your end point. Okay, this really depends on what points you are picking. Here, since we have A and B, that's how we have RB/A. The order also matters. Remember, RA/B does not equal to RB/A. They're 2 different things. And the order here, B/A, depends on who is first. Since here we have VB is first, VA comes second. That's why we have VB/A. If we flip A and B, that slash also flips. Okay. Omega is the angular velocity of the rigid body. Now the question on that. Just for this rigid body, just give a wild guess. How many angular velocity does this rigid body have? Raise your hand if you think it should be only 1. Okay, 1. Okay. Raise your hand if you think, there should be 2. Okay. Now raise your hand if you think there must be three different angular velocities. No, no one choose three. How about there's infinite angular velocities? Raise your hand. I mean, there are millions of points that they all have their own angular velocity on the rigid body. Raise your hand. No, hand off. Okay, the correct answer, make sure you write that down. There's only one angular velocity for a rigid body. There's only one. Okay, so this is the first equation, the velocity equation. That tells us if we want to find out a velocity about a point on a rigid body, we have to know three things. We have to know the velocity of another point and also angular velocity. And we also want to know what is the distance of position vector between these 2 points. So when you want to find the velocity, you have to find out those three informations before you can apply this equation. Okay. Now let's look at the second equation in this section. Acceleration of a point. In this case, let's use point B. The acceleration of point B equals equals AA, that's the acceleration for point A, plus omega cross product omega cross RB/A plus alpha cross RB/A. Okay, this is why I'm saying at the beginning of the semester, the equations in this course are getting longer and longer. Wow, this is the equation for acceleration. Look at how many cross product we have. Those are all cross products. Anybody knows how to do a cross product? Raise your hand. Okay, what's the result of a cross product? Do you get a scalar or vector? Vector, yes. The result of cross product, it's vector. Okay, that's pretty long, right? Well, there's a easier version of this equation. Let me tell you what's the easier version of this. For this course, since we're only talking about like 2 dimensions, so we can simplify this acceleration equation down to AB equals AA minus omega square RB/A plus alpha cos RB/A. So this is a simplified version of this equation. And for most of the calculations, you can use the simplified version. It's fine. They're equivalent. I want you to make a note here. Look at what is this? Omega. Do I have a vector sign notation? That's right. Write it down. That's a scalar of that angular velocity, omega. There's no vectors. The scalar omega square. Okay, so in this equation, we talk about omega from the velocity. Oh, sorry, there's a mistake I made here. This vector, this position vector has that vector notation. Okay, there's a new guy inside of this equation. Who is new? Alpha. Alpha is a new guy here. Make a note here. Alpha is the angular acceleration of the rigid body. It's the angular acceleration of the rigid body. It's so question here. This AA and AB, they're both called acceleration. And this omega is also called angular acceleration. Wait, what's the difference between omega and A? Yes, that's a very good way to explain this. The units for alpha is different. Alpha is the angular acceleration. That's how fast the angular speed is changing. So the unit for that is radius per seconds square. But for the acceleration here, AAAB, they are the linear acceleration. So the unit for linear acceleration is just meter per second square. So they're totally different accelerations. Okay. Those are the new equations we want to use in section 2A. Now let's look at an example how to use those equations. If you have a textbook, I want you to turn to page, I think it's 97 or something. It's example 2A1. Okay, turn to a page. What page is that? 93. 93. If you have a textbook, turn to page 93, example 2A1. Could I have volunteer to read this problem for the rest of us? Sean, do you mind?
The disk shown rotating at a non-constant rate, about a fixed axis passing through a center O, where at a particular instant, the acceleration vector at point P on the disk AB. Determine the angular velocity of the disk at this instant and determine the angular acceleration of the disk at this instant.
Thank you. Okay. So just based on what is there, write down what are the givens and what do you need to find for this example. Okay, so I have everything set up for this problem. We're given that disk is fixed at point O, so it can rotate about that point O. Point O is a fixed point. And we also know the angular speed of that disk. So the disk is a rigid body. We know the angular speed of that disk, omega. And we also know at point P, this is the acceleration. And we know the distance from O to P, that's R. What we want to find is what is the speed of point P, Vp, and we also want to find out what is the acceleration, angular acceleration of this disk, alpha. Okay, let's first look at first question, Vp. I want you to just try it out yourself, maybe 3 minutes. Look at the notes, look at what's the equation for velocity for rigid body, and try to apply that to this example. Yeah, use the equation we learned from today, the velocity equation. Set up your velocity equation. Okay, from that equation we learned today, this is the equation we learned for chapter section 2A. We know we want to have 2 points, right? This point on the left-hand side, that's the points you want to find about velocity. And you need to know another points that you know velocity, and also omega and rb slash a. In this example, which point we know velocity? Is there any point we kind of know the velocity? We know we must have Vp there on the left-hand side of the equation. What is another point? Y point O.
Just with the equation, it doesn't really move, so it's at a constant velocity of 0.
Yes, point O is fixed, it doesn't move. So any fixed point has velocity of 0. So that's what should you have. So you should have point P and point O. So the equation gonna look like Vp, that's something we're looking for, equals Vo plus omega cross product Rp slash O. Yeah, keep that in mind. It's important that R has to be Rp slash O because P is the first and O is second. It's P slash O. Like we said, this VO is 0, it's a fixed point. So we can find out what is Vp. So Vp equals omega cross Rp slash O. Let's first figure out what is the vector form of omega. So what is a vector form of omega? So it has a vector notation. So we know it has to be some number plus a unit vector there to be a vector. But the angular velocity and angular acceleration, they're kind of indifferent. They're not on I and J planes. So if your disk is rotating counterclockwise, actually your thumb, if you use your right hand, your thumb is pointing to the direction of unit vector. So if I do this, my thumb is pointing out of this whiteboard. So that's the unit vector direction for our angular velocity. And we call it K. So it's K hat as the unit vector. In this case, we know the angular speed is omega, and add that unit vector, which is K. That's how we express angular velocity in a vector form. Okay, now let's look at RP/O. Can someone tell me what is RP/O? That's just a vector. We know R, the distance between P and O, is 0.4 meters. So what is this RP/O vector equals to? It's on I and J coordinate system. Can someone tell me what is the vector form for that RP/O? It should equal to something I plus something J. What is in front of I? I. So that vector is from point O pointing to point P. I direction is this direction, 0. What's the number on the J direction then? That would be 0. How about I direction? Yeah, pointing to that direction, which is negative direction of I. That is your negative, that will give you negative sign. And the distance is 0.4. So RP/O as a vector should be negative 0.4I plus 0J. There's nothing on J direction. Okay, now it's time to practice your cross product skills. What we left with is this omega K cross product negative. Let's replace that with just negative RI plus OJ. Let's use symbols, don't use numbers. R. Okay, now it's your job to do this cross product. You're gonna tell me what's the result of omega K cross negative RI. All right, do the cross product on your note. Okay. Raise your hand if you have an answer. Okay, Holden, what's your answer for this cross product? Negative omega RJ. Yes, that's a correct result for that cross product. For the rest of you, do you have the same answer? Raise your hand if you got the same answer. Okay, if you didn't get the same answer, tell me who told you the cross product. Which professor? I can give him a phone call. Okay, but cross product, if you don't know how to do cross product, in your textbook chapter 0, and there's reviews on how to do dot product, how to do cross product. So make sure you go back to read chapter 0 on your book. Okay, so now we have it. This is the answer for VP. The velocity of a point on the rigid body. Now let's look at the second question. We want to find out what is alpha. Okay. Is this my imagination or is this true? I feel like everyone is very sleepy today. It is? Okay. How about let's all stand up. Stand up, then wake up a little bit. If you can fall asleep this way, then I have nothing to do. Okay. So everybody is standing up. Now, let's look at how to find alpha. From the two equations we learned today, which one has alpha? Acceleration. We see alpha instead of that equation there. Okay. So if we want to solve alpha, we have to figure out what is this guy, this guy, this guy, this guy, this guy, right? Okay, so in this example, do we know any point that acceleration is given? Since we need to know two accelerations at two different points. In the problem we're given, at which point we know that 3i plus 4j? P, that's point P. So we know one point that has acceleration 3i plus 4j. Do we know the acceleration of another point? Origin, point O. So what is acceleration for point O? 0. Okay. Yes. We got this figured out, that figured out. Do we know omega? Yes, omega is given. Do we know R something slash something? If we're talking about P and O, that's RP slash O. Yeah, we kind of know that. Okay, now you can sit down to apply this equation, plug in everything you know to see if you can find out what is alpha. You guys know what my feeling was when you all stood up? That was a moment I realized, damn, how tall you guys are. It's like, oh. Okay, I'm gonna set up my equation on the board so you can compare yours with my solution. So I will set AP on my left-hand side of the equation equals AO. That's a 2-point we know acceleration. I'm gonna use the simplified version of that acceleration equation, which is minus omega square rp/o plus alpha cos rp/o. Okay, so this is the correct way to set up this equation. Raise your hand if you got exactly the same equation for your equation. Okay, good. That's the correct way. Be careful that order p/o, p/o. If you have o/p here, I'm sorry, you're going to take 2 points off from there. Okay, now let's look at this guy, alpha. Previously, we have this omega. We know we can write that as something k. The same deal applies for alpha. Alpha as a vector can be written as alpha on k direction. K is a unit vector for all the angular speed, angular velocity, and angular acceleration. All right. Now your job is just plugging everything you know for AP, AO, omega, RP/O. AP, we know is given as 3I plus 4J. AO is just 0. And here we end up with plus omega square R on I direction minus alpha R on J. That's a cross product between R cos alpha cos RP/O. Okay, I want you to stop here. Here is just when you plug in all the stuff you know, you end up with this vector equation. On the left-hand side, we have that AP, which is 3I plus 4J. On the right-hand side, we have this symbolic something I plus something J. Okay, this is the vector equation. How do we solve alpha? This is very similar with the stuff we did in chapter 1. Whenever you have a vector equation, that means on one hand of the equation, you have something I plus something J. Another hand, something I plus something J. And there's an equal sign. What does that mean? That means these two vectors is equal. That means if they're equal, everything in front of I should be the same. Everything in front of J should be the same. Right? Remember that? So you can always break down a vector equation to two scalar equations. So write the notes down, break down into two scalar equations. The first scalar equation is on I. It's for the I components. You write I, add a column. So on the left-hand side, you have 3. You only take the numbers and the values in front of unit vector I equals. On the right-hand side, in front of I, we have omega square R. That's the first scalar equation. The second scalar equation is on the right-hand side, on the left-hand side, we have 4. That's a value in front of J. On the right-hand side, we have negative alpha R. Okay. I'll look up here. you break this vector equation into two scalar equations. Any questions? This is a very important technique. So we're going to use again and again to build a vector equation, break it down to two scalar equations. Why we want to break it down to two scalar equations? When you look at that second scalar equation, it's very easy. It helps us to find out the unknowns. In this case, alpha is unknown. R is given as 0.4. Alpha 4 equals negative alpha R. That's a very simple, easy equation that you can find out what is alpha. Alpha equals negative 4 over R. That's your answer. So review this example since this is a technique we're going to use again and again in this chapter. Alpha equals negative 4 over R. And that radius per second squared. That's a unit. Okay, I have 4 minutes left. I want you to go back to the beginning of this example, look over what you did, and review what we learned today. So far, at least I told you, I didn't lie to you. The equations are getting longer, right? You definitely saw the acceleration equation are longer. Well, we didn't stop there. In chapter 3, the equations are nasty. Super long. Super long. You will see that. Okay, so that's all we have for today. Make sure you start your homework for 2A early. All right, and have a good weekend.